Hi guys. All right, so today we're gonna go over that exit slip that I just gave you. Here we go. I kind of got you started on it. I told you to kind of graph the y equals 2 to the 2x, and I gave you an xy chart for it. So let's do this first. Let's just kind of, let's see how you did. It looks like people did pretty well on it, a lot of people. All right, so when I plug in -1, I'm going to get 2 times 2 to the -1. Which again, you don't multiply 2 times 2 first. First you do the power, you do 2 to the -1, which is 1 over 2. Okay, which is 2 over 2 to the 1, which is 1/2, and then multiply it by 2. So it's 2 times 1/2. It's 1. So when you plug in -1, you get 1. So I'm plotting that point. All right, next point. 2 times 2 to the 0. Well, 2 to the 0 is just 1, so 2 times 1 is 2. So when you plug in 2, you get 2. All right, let's plug in 2. 2 times 2 to the 2nd, so that's 2 times 4, which is 8. So when I plug in 2, I get 8. 2, oh, maybe I should have done to the 1. All right, well, whatever. 2, 3, 4, 5, 6, 7, 8. Okay, if I did plug in 1 just for the heck of it, it would be 2 times 2 to the 1, which is 4, right? So 1, 4. Might as well throw that point in there. 0, and I don't know why I plotted 0, 2, 0, 3, sorry. Let's do that again. It should be 2, it should be the point 0, 2, sorry. Okay, and then last one I had here is 2 times 2 to the 3rd, so that's some really high number. It's 2 to the 3rd is 8, 8 times 2 is 16, so we don't have to do that one. We'll just leave it like this. Okay, that's the graph of that, all right? Now we got to start shifting things. So this -1, remember, is a horizontal shift. We're going to shift 1 to the right. And this -4 right here on the outside, not in the exponent, is going to mean up or down. So this is 4 down. All right, so we're going to take each one of those green points and shift 1 to the left, and I'm sorry, 1 to the right and 4 down. So 1, 1, 2, 3, 4. 1, 1, 2, 3, 4. Oops, that's not a point. And then 1, 1, 2, 3, 4. Okay, so that's the graph. Something like that. Okay. Hopefully you guys got it. That's what I saw kind of when I looked quickly. All right, so we're going to start talking about interest right now. My notes are a little bit weird. I hope yours aren't. Like, look what happens. I'm on a blank screen and all of a sudden it just kind of starts coming. Yeah, not good. I feel like it's corrupt, these notes, but anyway, we'll try. If you had $1,000 and you earned 5% interest, how much would you have after 1 year? Well, this is actually the formula you're going to use, right? You would say y is equal to the initial amount, which is 1,000, and your rate was 5%, and so this is growth. Whenever you're earning interest, it's growth. So it would be 1 plus 0.05. 5% equals 0.05, so you'd have 1.05 to the first year, okay? So if I did this out and I figured it out, I would end up getting, oh, do I have a calculator? It would be 1.05 times 1,000. All right, hold on. 1.05 times 1,000, 1.05 times 1,000. So at the end of 1 year, I would have $1,050. Whoops, let's write that right. $1,050. Okay, so I earned $50. So in the following year, think about it. In that next year, now my initial amount is going to be $1,050. Okay, so this is something called compounded interest. Okay, compounded interest. If that interest, so in other words, now that $50 that you just earned is going to earn more interest in the following year. So compounded interest, we have to use a different formula. Here is your formula for it. It is A is equal to P times 1 plus R divided by N to the NT. All right, here's the deal. P is the principal, meaning the original amount. Okay, and N is the number of times you're going to compound per year. So if you have interest that is compounding monthly, N is 12. If you have interest that is compounding quarterly, that means 4 times a year, then n is 4. It compounds 4 times a year. Okay, if it's semi-annually, you would have n is equal to 2. All right, now think about this. That also goes up into the exponent, because if now your interest is, let's say your interest is now compounding monthly. That means 12 times a year your interest is going to start earning interest. So that over a period of, say, 2 years, now instead of it's going to compound 2 years times 12. So it's going to be 12, your exponent would be 24, not 2. Okay, so this is kind of an example. You invest $2,500, which will earn 4.2% interest compounded monthly. How much will you have in 15 years? So here's the deal. Your answer, and it's always like A for some reason. So here's your formula again. Let's just write it again. A is equal to P times 1 plus R divided by N to the NT. All right, so A is equal to 2,500, that's your original amount, times 1 plus your rate. Well, your rate is 4.2%, which is going to equal 0.042. And if I add that to 1, it would be 1.42. All of that to the, oh, and so I'm sorry, and it compounds monthly, which we just said that's 12 times a year. So it's the rate divided by 12. And then it's going to be for 15 years. So R to the NT. So 15 is the T, but we have to multiply 12 times 15. All right, if I do this out, I get 2,500 times 1 plus, okay, so here's what I'm going to do. I'm going to go to my calculator. I'm going to take 0.042. 0.042. I'm going to divide that by 12. I get some crazy decimal. Well, not that crazy. It comes out to be 0.0035, and I add that to 1. Okay, I take that 1.0035, I put it to the 12 times 15 power. So I'm going to put it to the 12 times 15 power. So hold on a sec. I have like not a great calculator here. So 12 times 15 is 180. So it's, hold on, 0.42 divided by 12 plus 1 equals that. And it's to the 180th power. And I get this crazy decimal, and I leave it in my calculator. I don't round in there. Don't round until the very end. Then I multiply that by $2,500. I get this. So this is 1.0035 to the 180. So when I did this whole thing out, I got $4,688.87 if I round it correctly. Okay? All right, let's keep going. I want you to try this one here. You are now investing $5,000, earning 2.5% compounded quarterly. How much will you have in 7 years? So pause the video and give it a shot. Okay, we're back. Here's my formula again. A is equal to P times 1 plus R divided by N over to the NT. All right, so A is equal to the principal, which is 5,000, times 1 plus the rate. The rate is 0.025, right? Divide that by 4 because it's compounding quarterly, 4 times a year. And that to the 4 times 7 power. So if I do this out, 5,000. I'm going to do it out on my calculator. I'm going to take 0.025. Hold on. So I got 0.025. 0.025. I'm dividing that by 4. I get 0.00625. I add 1 to that. I put that to the 28th power, right? Because 4 times 7 is 28. I get this crazy long decimal. I multiply that by 5. 1, 2, 3, 5,000. I get this. So this is, I'll just cross that out. 5,952.99. Hopefully you guys got the same answer. Okay? Hopefully I didn't mess it up. Okay. What does it mean when the interest is compounded continuously? So let me just tell you. It means it is compounding 24/7. Like constantly compounding. That is realistically the type of interest that you get when you put money in a bank. Okay? All right. So let's kind of look at this quickly. This is not the most important thing, but I got to show you this. If I just said that x is the number of times, okay, that it compounds, that's like your, you know, your n, it's the number of times. So in this case scenario, x is the number of times it compounds, number of compounds, right, per year. All right, look what happens. If I plug in 1, I get 2 to that formula. So because it would be 1 plus 1 over 1, which is 1 plus 1. That would be 2 to the 1 power. It was just 2. If I plug in 10, I get that. Not much more. If I plug in 100, I only get that. If I plug in 1,000, I get that. If I plug in 1,000,000, I get something like somewhere around 2.718 something, something, something. So listen, if I plugged in 1,000,000,000,000, it would be a little bit higher than that. So this is some number, and this number is called E, and that's how we get this number. And this E is kind of like pi. It's a constant, but it's an irrational decimal that just goes on forever and ever and ever and ever. Okay, so we're going to use this formula for compounding, for computing compounded continuous interest. Anytime you hear the words compounded continuously, you're using this thing called the PERT formula. Okay, here you go. That's your principal. Okay, is it P-L-E? I always forget. Let me go see. How did I write it back here? Principal with an A-L. All right, not the most important thing. A-L. All right, E. E is just done. It's right there on your calculator. You can use E. All right, R is the rate, and T is the time. This is a really super duper easy formula. Okay, you invest $4,000 with 2.5% interest compounded continuously. How much you have after 10 years? So here you go. Here's your formula. A is equal to your principal, P to the ERT. Hold on, let's put that first. So my principal is 4,000, and it's times E to the rate. We got to convert that to 0.025. If you put 2.25 in, that means you're like more than doubling your money. That's not the case. 0.025 times 10. Now you can go to your calculator and you could put it in exactly that way, and you have an E button on your calculator, if you're on your graphing calculator. So here's what I'm going to do. You ready? Here we go. This is going to be 5,000. See if this works on my calculator. Times E. Whoops, that didn't work. I have to do something different. So 5,000 times E to the, hold on, I screwed up. E to the 0.025 times 10 equals that. That's not right. Let's do it this way. E to the 0.025 times 10 equals, and then I multiply that by $4,000, and I get this. That is totally wrong. Okay, I need a better calculator. But this is what you want to plug into your calculator, okay? We can talk about it in the next class on what you get, all right? Trying this again. All right, you know what? Here's your exit slip. We're going to make one up for you guys right now. Here you go. You ready? 2 questions. 1, you invest $1,000, earning 1.75% interest, compounded quarterly, for, I want to know how much you're going to have in, how much, or okay, let's say for 8 years. Okay, how much will you have? Okay, that is your exit slip for that. I'm going to do number 2. Let's say now instead, hold on, instead, whoops, let's write the word right. Your $1,000 is compounded continuously at 1.75%. So you should think about that. The more it's compounding, the more interest you're getting, because your interest is earning interest quicker. All right, there's your exit slip. Hope you guys did okay on this, and I will talk to you guys. We'll meet next time for class. Okay. All right. Good luck. Bye.